Data streams. Data streams are streams whose sources and destinations are other streams, such as file, buffer, network, piped, and so on. Data streams are also known as wrappers because they wrap the primitive stream object mechanism inside a more powerful one, by means of providing additional functionalities. They provide functionalities to read and write Java primitive types. Data streams are buffered. They process more than a single byte at a time. Data output stream. Data output stream extends filter output stream, which further extends output stream. Data output stream implements data output interface. The interface defines methods that convert value of primitive type into byte and then writes to the underlying stream. Data output stream must be attached to some other output stream. It cannot be independently operated. Example, data output stream is attached to a file output stream. To write to a file on a file system named file1.txt. Here I have created an object of file output stream passing file1.txt as an argument, further passing the file object to the data output stream object. Data input stream. Data input stream is a complement of data output stream. The data input stream extends filter input stream, which further extends the input stream. Data input stream implements data input interface. This interface reads a sequence of bytes and converts them into values of primitive type. Example, data input stream is attached to a file input stream to read a file on the file system named file1.txt. In this code here, we have created an object of a file input stream passing the file name file1.txt as an argument, further passing the file input stream object to the data input stream. As you see here, data input stream dis is equal to new data input stream passing the file input stream object. Now let's look at how to implement data input stream and output streams. In this example, I have imported data input stream, file input stream, and 3 exception classes: file not found exception, IO exception, and end of file exception or EOF exception, as you can see at line 1 to 5. In public static void main at line 13, I have created an object of data input stream. Passing a file input stream object as parameter. At line 16, I am calling the method readByte on data input stream object. The method returns a byte which is converted and printed at line 18. Here is the byte converted to char and printed in system.out.println. The method readByte throws the end of file exception on reaching end of file. In fact, all reader methods of data input stream throw the end of file exception. The rest of the code in this example is similar to the previous examples discussed. You can try out the example from Java Virtual Guru. In this example, I'm using a file input stream, a buffered input stream, and a data input stream. At line 16, I'm creating an object of file input stream. Further, at line 18, I'm creating an object of buffered input stream, passing the file input stream object as a parameter. This implies that the buffered input stream is wrapping the file input stream object. Further, at line 20, I am creating an object of data input stream, passing the buffered input stream as a parameter. Here, the data input stream object is wrapping the buffered input stream. At line 22, I am calling the method readLine. This reads one line from my data.txt file. You could find this example as a part of Java Virtual Guru reference number 7.3.2. In this example, I would demonstrate you how to read and write primitive types using data input and output streams. At line number 10, I have created an object of a data output stream, passing a file output stream as a parameter. Here, invoice1.txt is the file pointed from the file output stream. Further, I have created a double array price and then an integer array units and string array description. And further, I have a for loop starting at line 14. Here is the code which writes the price, units and descriptions to the file. As you see, write double. Write char is a separator used between the records. And further, each record is separated by a new line character. Here is the code which writes the data to the file. Out.WriteDouble writes a double value to the data output stream, further to the file output stream, and further to the invoice1.txt file. I have a field separator /t, that is a tab character, followed by writeInt, which writes the integer units, and then a tab separator and further a description. I have used a new line character to separate the records. Further, at line 25, I have created an object of data input stream, passing a file input stream object as parameter. And then at line 33, I am reading int.readDouble. Then read char. It's important for you to remember the order of writing the primitive types while reading them. As you might have seen earlier, I have first written a double value followed by a tab character. So I am reading a double value followed by a read char, which would read me the tab character. Further, I am using a readInt to read the number of units. And then a read char to once again read the tab character. Further, to read the description, I am using a simple while statement. I would read the description until I reach the new line character. Having read the description, at line 43, I am printing the record. The loop continues until it reads all the records and finally throws an end of file exception. You may work on the example from Java Virtual Guru. Stream tokenizers. Stream tokenizer reads text streams as sequence of tokens. For example, if I have a stream which has both characters and numbers embedded, and then I intend to only read the characters or words, then I can set the tokens accordingly and read the stream. Let's consider an example. In this example, I am creating a string reader which consists of both characters and numbers. At line 5, I am creating a string tokenizer object, passing the string reader as a parameter. The method reset syntax is used to clear the defaultly set tokens. However, it may not be required in this example. I am using the method wordChars to set the range of characters that I intend to read. At line 9, I am repeatedly calling the method nextToken and checking if the token returned is not EOF. However, if the token returned is equal to tt_word, I am printing the sval. This prints you the words. You may refer to this example from Java Virtual Guru. Here is the source code of this example. Here is the output. Excluding the numeric characters, it prints you the words. You may refer to the example from Java Virtual Guru.